Okay, testing. Welcome to Programming Rainbow. In this video, we'll continue on the series of Don't Eat the Yellow Snow in C in SDL3. This is the third video. If you'd like to follow along with this one, you can go to github.com, Programming Rainbow, and this will be called Yellow Snow C SDL3. Okay, I'm going to show you what the project is going to look like at the end. So I'm going to compile. If you've just, if you've just git cloned this one, what's in the source directory will be the final project. Please. Okay. So if you just clone this one, what's in the source directory will be the final project. But since this is what I just ended up with in the last video, I'm going to compile what's in video 8 by specifying the source directory as video 8, make run. I'm going to do a make clean run and mute the video or the audio, and you have a snowman, and we can go all the way to the screen and it stops, and we can go to this side and we have a score. And if we ever hit the yellow snow, the game ends, and we can press space to reset it. So that is the game that we're creating, and we're controlling it with the arrow keys or the A and D keys. Okay. The project after this one will be taking this project and adding a neural network so that we can train its own neural network and tell it to play itself. And here is a view of what that looks like, where it's playing itself with its own neural network that has been slightly trained. And I can't mute the music on this, sorry about that, but you can kind of see it's making its own decisions. It's, it's doing okay. It's not the most brilliant, but, it's doing what it does. And so this is running off of a neural network that this will be the next project that we make. This is a neural network in C, and it has no special modules or anything else. This is all done just in basic C. Okay, so I'm gonna let this in for the when it finally decides to hit a yellow snowflake, and then we'll continue on. Okay, there it goes. Okay, so let's show where we ended off with the last one. So I'm gonna make what is in the source directory for me. Since this is video number 3, if you just clone this one, you're gonna wanna probably delete the source directory, copy what's video number 2, and then rename that, or rename the copy of it to source directory so you can follow along with this video. But I'm just going to show you what we left off with. We have a background, and we also have a sprite, or sorry, a icon for the Windows icon that I can't show because I'm using a tile in Window Manager. But in this video, we're going to be adding the player and the player movement. We're going to try to do all of that at once. So the first thing I want to do is just load the player. So if we look up here at our images, player image is called player, and we already know how to do this. So I'm just going to get right to it. Load media. It's going to look exactly like this one. We do need to go into game H and add this, and we can just call it player. I'm just going to double check my notes just to make sure that I am calling it the right thing. I called it player image. That makes more sense because I'm going to have a player module in a second here. So I'm going to add here, I'm going to say SDL texture, just like the other one. And this is pointer, and it's going to be called player image. I'm going to have an actual player here too, so that's why this is happening. So in load media, I'm just going to grab this right here. It's going to look exactly like it. Copy that, paste it here, and this will be player image. And the image that we're loading is just called player PNG. We are checking the pointer for player image right there. And the error message is the same. That looks great. That's done. And then we can go into game. And just like this one, whoops. I guess it considered a right mouse button click or something. I'm not sure. So this is player image. And finally setting it to null, like we've already done this before at the background, so it's going to be the same. Okay, so that gives us an image that we have loaded and we've unloaded. but we are not going to display it. I mean, let's just display it real quick, but this is not how we're going to actually display it. So I'm just going to yank this one here, and just to make sure that this is in fact loading the player. And we know that's going to look wonky. Again, this will be fixed in a moment, but let's just make sure that it is loading and unloading. Yes, that looks great. And let's see if we have any memory leaks. We shouldn't. If we run make debug, this will be looking at, yeah, that has my, it checks on Linux. I don't think it does it on Mac, but it checks if I have memory leaks. Okay, so that's great. The image is working and all that. But what we really want to do is we want the player to exist in its own kind of module. So it's going to be, what we're going to do is have a player struct, and that player struct is going to be a member of game struct. And then that player struct will have its own functions that operate on it. So we are going to end up with a player file over here. Let's just do that. Player C and player.h. So in player H, we're going to, let me check. I believe we are just going to include main. Yeah, okay. So we'll do the if and def, and then it'll be player H find player H, and then we'll get rid of this nonsense here. So I want to include main. So that gives us access to everything we need as normal. And then we want to define our player struct. So what we're going to do with this is the player is going to be able to draw its own image. So it's going to hold a pointer to the image. Even though we've loaded the image in the game struct, we're going to pass a pointer to it into here. So it's going to have its own pointer image. We're also going to pass a pointer to the render. And this is going to allow the player to draw itself. So even though the resource is held in game still, the player we can just tell player, hey, draw yourself. So we will need that. And also, to be able to draw how we saw the snowman is stretched, because we don't have a rectangle. We need a destination rectangle. So we are going to need the width and the height of our image. So a rectangle in SDL3 needs to be an frect, which is a rectangle of floats. And in SDL2, it was a rectangle of ints, but it is floats for SDL3 that we're going to be using. So it's called an frect. And we're going to get the width and the height with this function called SDL get texture size. I think it was called query texture or something like that in SDL2. But this returns floats, so we can populate our rectangle's width and height directly from that. And then when we go to use SDL render texture, we can use this rectangle that we have to actually draw it the correct size. So that's what we're doing. We are going to need this rectangle right here that we're going to populate. So I'm going to add this in here as well. So we're going to say SDL render. Okay. And that's just going to be a pointer. We're not creating a new renderer. I'm just going to copy the pointer in. SDL texture. And this again is actually in game. So I'm just going to copy the pointer in. I'm going to call it image because it's the player image. And we need this SDL frect. And the F and R are both capital. So it's like a float rect. We will be adding more stuff later. Let's just do this right now. And we need to frect. I'm just going to call it rect. And it's not a pointer. It's just an actual rect. So we need the semicolon here, and then we will have some functions. Hold on, let me cough. So we're going to have some basic functions. It's going to be player new, player free, player draw. Well, let's start with that. So I know new can fail. I know free just cleans up memory, and so it's not returning failures on that. And player draw is I'm not checking failures on that because that's happening in the game loop. So those are going to be void. Okay. So we've already seen this before in game. See these functions right here? They're going to look just like this. I'm actually going to write them out because otherwise I'd need to rewrite this game over and over again. Oh yeah, but no, I'm just going to write it out. But they're going to, it's very, very much the same idea. So we'll say player new, and this will be struct player, and then a double pointer to a player. Player is a pointer to a player struct. And we are actually going to be passing in the renderer and the image as well. So we are going to need this SDL render because renderer exists in game. So we can just pass the game one in here, the pointer, and then we can just hold the pointer locally. So I'm going to call that render. And then SDL texture, we'll call it to image. So we're going to pass these two in and set them into the player. So now we have void, player, free, and this one is struct player, and a player is a pointer to a player struct is the same thing because we are affecting the address in this function just like we did with game. And then we have void player. This one is draw. Now draw should not be affecting the information held in struct at all. So I'm going to say const struct player, and I'll just do p as a pointer because I use the whole word when it is this double pointer. Otherwise, for simplicity, I just say p because I know I'm working with a player function. P means player. Very simple. Okay, so I'm going to copy these, and we'll go into player C, and we need to include player H, and then we can put these in here. I'm just going to put some open and close. Okay, so we are going to do this the exact same way that we did game, as in we are going to allocate this on the heap, just like we did with game. So we used calloc. So we have to dereference player one time. So we're using calloc because we want a memory to be initialized to zeros. We just need one of these, and then we're going to say size of struct player. And then if this fails, we can check the pointer here. So if player equals null, something went wrong. So we can say f printf std error, and this one will be error in calloc of new player. I think that's good enough. And this is not an SDL error, so we're not getting anything from SDL. Return false. Now, if player is good, I'm going to go ahead and immediately create a local variable called p, just so I can use it over and over again. So I don't have to keep dereferencing player. So the first thing we can do is take the render and the image that's being passed into this function and set them. So we have p render, right? And we can just take that render that's being passed in here and set it. And then we can take the image that's being passed in and set it to our image. That's pretty simple. Now what we want to do is we have this image, but we don't have the width and the height. We do have a rectangle, but it's all zeros right now. So we need our width and our height. So we're going to go jump to this function right here, this SDL get size, and this we need to give the pointer to the image, and we need to send in the address of the width and the height, okay? Because we're changing it inside the function, so we need the address of it. And this can fail. Sorry, if it fails, it's going to return failure. SDL3 always returns failure as a false, and success is a true now, which is kind of opposite of SDL2, but makes more sense. So I can just put a bang on it, and I can say SDL get texture size. So we need the actual texture, which is the P image. And then we need to send in the address to the width and the height. So it's going to be p rect dot width, right? But we need the address of it. And the same, the address of p rect dot height. Okay. So if this fails, we're going to just print a message for ourselves. Error getting texture size. I guess I put size as capital. So this is an SDL error. So I'm going to do this with a %s for a string. And like that. And we'll say SDL get error. This is not meant to be. There we go. And then we can just return false out of this. Okay, I'm going to put the return true so it doesn't complain because this is a bool. So that is getting the width and height. And that's going to be good enough for right now. Let's deal with the freeing of the player. So just like in game, the very first thing we want to do is make sure the player pointer itself is actually valid. So, and we need to dereference it one time. Okay, so that takes care of that. Now I'm going to do the same thing. I'm going to make a local. So P, I'm going to dereference player one time. Otherwise, you have to write up, you have to keep putting this player in parentheses, when you're doing stuff. So now if the I'm just drawing the player texture inside. In my notes, I'm destroying it inside. I shouldn't be. That's weird. Hold on. I guess because I'm always checking, if I destroyed it 2 places, it doesn't matter. Yeah. Okay. So in my notes, I'm destroying it in here, which I shouldn't because it actually belongs to game. It's just a pointer. But the fact that I'm actually checking, and also SDL is checking too, it doesn't cause any errors. But we don't need to do this because the image is being freed as part of game. So all we really need to do is we're going to set it to null. We don't even need to do that because we're going to free game itself too, but I'm just going to do it for good practice. So let me flip back on my notes. That was kind of weird that I was freeing it. In one version, I probably was probably having player load its own image, but for this small project, it's okay to let game do it. So what I'm going to do is I'm just going to take the image. I'm going to set it to null. Okay, because remember, this image is actually owned by game and it's being cleaned up in game. This is just a pointer. This is like a secondary. I have 2 pointers pointing to the same image. This one, I just don't need the pointer anymore, so set it. The same for the render. Is going to be null, right? Again, the render is being cleaned up in game, not here. We will have more stuff in a minute, but this is good enough for now. We actually need to free the memory allocated to the actual player struct, okay? So we can do that here with free P, and we'll set P to null, just for good practice. And this won't actually change the original pointer, the pointer that's being held in game. We want to set that to null too. So if we dereference player one time, and then we set it to null, that will sort that out. So now at the end of this cleanup, the actual pointer being held in game for player that we haven't created yet will say null after this is done. So that'll be good. And I'm going to give myself a message too. This is not an fprintf, just a normal printf because it's going to standard out. And I'm going to say free player. That's just so I visually know when stuff is being cleaned up. So that's kind of cleaning it up. Basically, we just need to free the player, but I'm setting these things to null. Now, drawing, I'm going to say SDL render. So I'm basically going to take the from game, this right here. I'm going to use this. We are going to change this actually in a minute. But I'm going to take this. Okay, so no G's here. We're in P land. And this is just called image. But our source is still going to be everything. But we do have a destination rectangle now. And we need to send in the address to this because we're just using a pointer for efficiency. So it's going to be P rect, which is our destination rectangle. So now the snowman should be drawn correctly, but it'll be in the top left-hand corner because the X and Y is still set to 0. Okay, so let's link this up. We need to go into game, and I'm going to add in this player right here. And down here under the image load, we'll call struct, and I'll just call it player. So that is there now. That's why we called it player image, because player is going to be the actual struct here. So we can go into game, and after we've loaded media, we can now load this. Let me go back. We can say player new. Yeah. This is the same. It could fail, so I'm going to put a bang on it. And this is going to be player new. And we need the address of the player, which is going to be G player, but we need to send in the address of it because it's affecting the pointer inside of the function. We also need the render, and then we need the image to the player image. And if this fails, any failure already has its own messages. We just need to return false because the messages were already generated inside of this function. Okay, so that's bringing that online. All right, it's allocating the player and doing everything it needs to do. So we need to go down here and we need to bring it offline. So we'll say if G player. And on this one, we don't need to set anything to null because player sets itself to null. Player free. But we need to send in the address to G player. And it sets itself to null. So because we've done that inside of the function. That's why we sent in the address to it right here, because we're affecting the actual pointer as well. Okay, so that's taking it offline. So now we should see a message, player free. But now we can tell player to draw itself. So down here, we don't need this one anymore. We can say player draw, and it'll be G player. And that should be that. Okay, let's see if that worked then. We can still reuse debug, that's fine. We don't really need to clean it now because we're working in the same source code every time. Okay, yeah, and we have the player in the top left-hand corner. That looks perfect. So when I close this now, we should get down here that it freed player, and then all clean. Yes. Okay, so we don't really want our player in the top left-hand corner of the screen. So we need to find out where to put the player. And what I'm going to do is I'm going to put the player right in the middle of the screen. Again. So if we go into player, actually in main, what is it? 737. Trying to remember the number. So I'm going to put in main where I want the player y-axis to be. It's just a magic number, so I'm just going to put it in here. And if it doesn't look right on your screen, you may need to just adjust it. I was just going to say player y. And yeah, this is live. Yeah, hello. So I'm going to put the number that I figured out where it looks like the snowman's on the snow correctly was 377. So I'm just going to put that. And now we go into player. So here is where I'm going to basically divide the screen, put it in the center of the screen, and then I'm going to use that magic number for the y. So p rect.x is going to equal, so we need basically the width of the screen minus the width of the player divided by 2. So I can say window this is defined in the header file. The main.h is where that's defined. P rect.w for width. And then I need to take this whole thing and then divide it by 2. And that will put the player in the center of the screen. Okay, for the y position, we're just going to use that magic that we set. Y equals, and I think it's just player y that we just put in main.h. And hopefully that's going to put the player in the center. Yes, there we go. Perfect. So we want to be able to move the player around. So we're going to move it differently. I want to get the state of the keyboard. So I'm going to close some of these, the rectangle, the get size. And so we have this function that says get keyboard state. And this is going to give us a pointer to an internal array that is being managed by SDL. We don't need to worry about the memory of this or anything. This is already created for us by SDL. We just need a pointer to it so we can index into this array. So this array basically is the keyboard, and we can use the SDL scan codes to index into this array. Okay. And it'll tell us the state of the key. So this is very much different from where we did it in game when we did the events. Right here where we have events, this is if an event happens. So like if I press the M key right now, I'm going to get one M, it's going to delay, and then it's going to start repeating M's. See that? We don't want that in our movement. That's an event, and that's a repeat and everything else. What we want to know is, in this frame, is the key down? If it's down, I'm going to move. No matter how many frames we have, inside that frame is the state of the key in the down. So this is not an event. This is going to be at the state of the keyboard. So I'm going to hold this inside the actual player. So this is just an array of bools. So it's const bool. So that's what I'm going to do. So inside player here, I'm going to say const bool key state. Okay. So that is going to be a keyboard state. And we're going to be able to index into that with SDL scan code, to know if a specific key is in the down or up position. So back into, I don't know why game is complaining about something. Oh, because I moved something in the, okay. So in player, we just need to set this up as well. So I'm just going to put underneath here. And I'm just going to use that function, that get keyboard state. And if we put in some kind of number into the function, or if we were to pass in the address of a right here, we would get how big the keyboard is. I actually don't care how big the keyboard is. I just want to be able to index it. So I'm just going to put null here. If you put a non-null here, it'll return the size of the keyboard. I don't need to know that information. So key state equals SDL get keyboard state and just null here. So that's going to set that up. Now we have this. We have a way to basically, we have the pointer to that array now, and we can index into it. And it's going to be 0 if the key is not pressed down, and 1 if the key is pressed down, or a bool, to true or false. So I'm going to make a new function here called update. Player update. And this will be struct player. A p is a pointer to a struct player, or a player struct. And so what we can do, like I said, we can just check it with an if statement. So we can say if p key state, and then we're going to index it with the SDL scan codes are very simple. They're just whatever they say. You know, SDL scan code A is the A button, B is the B button, right? You know, we've already seen this before. We used it with escape, and yeah, it's the same. So it's going to be SDL. If I say left or right, that's going to be the arrow keys, left or right. Scan code, right? So scan code left. Yeah, it's just in an if statement. So if it's left, we want to just kind of move it left, right? Rect x, and we'll subtract. Minus equals, say, 5. Sounds good. If p key state SDL scan code right, then we are going to do a p rect.x plus equals 5, and this is a struct. Okay, so I need to put this in the header because I'm going to call it from game. And we are going to make this better in a second here. I just want the minimum. So right here, update. And we don't have anything that's updating anything in game yet, I don't think. Yeah. So new function here. Above draw, below. So it's going to be above draw and below the inputs. Update. Game G. And all this is going to do is call player update player, just like that. That's all that this is doing right now. But we need to call this from here. So events, update, then draw. Okay, and I'm going to take this to forward declare it between events and draw. Okay, so hopefully if I've connected everything up right, we have a left, yes, and off the screen it goes, and right key, and off the screen it goes. Okay, cool. So what I'm going to do is I'm going to create a player velocity in a main H. Just double check to make sure what I wrote it as. Yeah, player velocity. And Yeah. I'll call it player vel, and it's going to be 5. Okay. Back into player land. We'll say player vel. I don't like to put magic numbers in code like that. And let's do some bounds checking. So after I update it, when I'm moving left, I don't want x to be smaller than 0, right? So if rect.x is less than 0, we have a problem. And we'll just set p rect.x to equal 0. And on this one, if width, if x plus width is bigger than window width, then we've gone off the right side. Dot x plus p rect dot w is larger than window width that is defined in main h. Then we will take window width minus, like, p rect.x will equal window width minus p rect.w. All right, let's see what that does. Okay, we stopped there. And we stopped here. Yeah. I actually wanted to stop closer to the edge. I'm going to count this as my bounding box, his head. And that's also going to count for collisions of the flakes as well. So we need an offset. So I'm going to put these again in main.h. And I just want to check what they are. It's like 40. Yeah. You may need to adjust these as well if it doesn't look right to you. So I'm going to say player left offset. And this is going to be 47. So player right offset is going to be 42. Again, this may not be right for you. And there's going to be a player top too as well. We'll talk about it more with collisions in another video, but I'm just going to put it in now. Top offset, and we'll say it's 10. Okay, so back in here. So I'm going to say the in player right here, it's going to be player. If player X is player X plus player left F, so I'm going to add it, plus player left offset. If these two together are smaller than 0, then I actually want to set this just to negative player offset. And this has got to be the negative one right here. And on here, I'm going to subtract the right offset. So minus player, and this isn't left offset, it's right offset. So if that is true, then we need to set it to, and it's going to be the opposite. So I'm going to be plussing it here. Player right offset. That's off. Okay, let's check that. And that looks good. And that looks good. I want the snowman to flip directions, so I actually don't want to use this SDL render at all. So if we look over here, we have this SDL render texture rotated. This is like an advanced version of a render texture where we can do other things. We can rotate, but we can also flip it. So that's what I want to do. So let's look at this. We have the render, we have the texture, we have the source rectangle and the destination rectangle. Then we have this angle. We have this center point. So the angle is going to be 0 because I'm not going to do anything with that. Center point, I'm going to put null in there. And this is what I'm less interested in, this SDL flip mode. Okay, if we open up SDL flip mode, we can have a SDL flip none and a flip horizontal. Okay, so this is going to allow us to flip the image. So let's just do that real quick. And the type of this is SDL flip mode. And what I'm going to do is I'm going to hold this inside of the player struct. And I'm just going to call this flip. And it should be set to none by default. I'm not sure if I'm setting it. No, I don't set it. So it should be set to none by default, the 0, 1. So what I want to do is I don't need either one of these. When I'm changing the directions here, when I'm going left, I need to flip it horizontally. So I'm going to say P flip equals, and this will be SDL flip horizontal. And when I'm going the other way, it's going to be none. It's going to be flip none. So I have these now. We need to change this down here. This is rotated. Rotated. So with rotated, we need the angle that we're rotating it, which is going to be 0. We need the center point, which we're going to put as null. And then we need this flip, if it's flipped or not. So this will be P flip. And let's check that out. Okay. Now I'm looking at where his mouth and his eye are against the edge. Now your window manager may be different than mine. That's why I said you may need to adjust the offset. It looks like on the right side here, it's not right. For me, probably, since I've fixed that one issue, it's probably going to be 45. 45. Let me just check it. Okay, let's call that good enough. You can look at it and play around with the offsets. So that kind of is doing everything we wanted it to do. So let me just cover what we did real quick. So we've added some stuff in here. This is the magic number of just where the player Y needs to be. This is the player's velocity. This is offset for right and left, so we can get kind of where his head is, and offset for the top we'll use in another video. In game, we are adding a new image texture, which is the player texture, but we're also adding in this player struct. So let's look at the player struct. Player struct holds a pointer to render, pointer to an image, but we're copying both of these in. It's got an frect, it's got the key state, and this flip. We have these functions, player new, player free, player draw. We've already seen these before. Player update, pretty simple and basic. We're passing in the render in the image. So in player, we are creating a new player. I'm going to get rid of that guy right there. We're creating a new player with callux, so we're passing in the address of the player. We passed in the render in the image. We make sure we have a good that the has been properly allocated to us. We are going to be passing in the render in the image to those members. we are getting the width and the height from this SDL get texture size, and we're passing the address of the width and height so we can populate those. Then for the X, we're just getting the center point, with the offset because of the width of the player itself. So we just take the width minus the width of the player, divide that by 2. That tells us where the X needs to be to draw the player in the center of the screen. And for the Y, we have that magic number that is set in main.h. Now we are populating this key state with this SDL get keyboard state. The null would return it would populate the address of a variable that with the actual size of that internal state. We don't need to worry about any of that, so I'm not worrying about it. The way we clean it up, since these are just pointers we're passing in, we are just setting them to null and freeing the memory allocated to player. And this one is crucial right here. Setting that to null sets the member in game to null. And we're giving ourselves a little message here. We are using that key state, and we can change this here. I'm just going to add in with a logical, write this. I'm going to say P key state scan code, and I'm going to say A. Okay. I'm just going to copy this one right here and put it here. And this one will be D, because D is kind of like the right key and A is like the left. You can do that. So if either one of these are pressed, it's going to do it. And we're basically moving it to the left with player velocity, and we're checking to make sure with the offset that it hasn't gone off the screen. The same with the right, pretty simple. We're using this new function, render texture rotate. We're not actually rotating it, so it's 0. We don't care about the center position, but we're putting it to null. And we are using this flip that we can set to horizontally flipped that we're doing here, or flipped none that we're doing there. So those are the 2 options. And I think that's about everything. So yeah, if you have any questions, there we go. So I think that's going to be everything. If you have any questions, please let me know, and I will see you in the next one. So have a good day.